I ain't gonna stop right now, no. Alright, take it on me, you baby. Alright, I never asked, do you wanna see my fire tonight? Take it with me, If I left, then it made no sense. And you tell your friends, and they want your hands, baby. Never mind. What if I left, then it made no sense. And you tell your friends, and they want your hands, baby. Never mind. If I left, then it made no sense. And you tell your friends, and they want your hands, baby. Never mind. If I left, then it made no sense. And you tell your friends, and they want your hands, baby. Never mind. If I left, then it made no sense. And you tell your friends, and they want your hands, baby. Never mind. If I left, then it made no sense. And you tell your friends, and they want your hands, baby. Never mind.
When the sun goes down, move slow. We get a little high. Oh, when the sun goes down, come close. We'll fade until we lose control. Every step we take, I can't fight this feeling. Take my breath away. No, we won't be sleeping. Move like shooting stars, run into the deep end. Dancing in the dark, it's like I'm dreaming.
Hello. All right. Good morning. Welcome to the last day of Apricot. Just a small housekeeping item. Tonight's closing social will be accessed by public transport. You can grab your token and BTS card from the reception or registration area, and that will get you there tonight. So today's session in here is a tutorial session. It is Git for network engineers. We have Philip, esteemed member of the community and troublemaker, presenting for us today on something that I think network engineers all pretend like we know, but we don't, and we end up at these sessions every conference to try and remember that we know Git. So please, Philip, take it away.
All right. So you may be wondering what's Trouble doing with a manners background. There's a story here. There's always a story. During the recent unpleasantness in early 2020s, people were looking for things to do and things to learn because everything was terrible. Oh, look, my computer is breaking. That's all right. I'll keep talking to the people in the room. So everything was breaking. People were looking for things to do, and people were realizing that, well, we're completely reliant on our automation now. So Aftab from ISOC and Manners came up to me and asked, hey, Philip, would you like to do a presentation on Manners, or on Git rather, for the Manners community, because they were collaborating on a document and discovering that most of the people they were collaborating with had no idea how to push things into a repository, pull diffs down, and do the things those of us who are forced to live with Git every day just do take as a matter of course. So that's why I'm using a Manners background. So we've got about 1.5 hours, I think. Given the vast number of people in the room, we'll probably come up a little quickly or a little early, unless there are many questions, which would be fun. So I'm going to talk a little bit about revision controls essentials. These are things software engineers take for granted, but network engineers are a little bit new to. Then second, present a survival kit, And then if we have time left, I'm sure we have discussion or more philosophical discussion about how you can use GitHub or GitLab or other services to collaborate using Git repositories. So the essentials of revision control can be summarized in one little line. Computers are better at remembering things than you are. It's their job, right? So revision control systems can help you remember changes you make to your network, so that you don't have to remember them. So if you have reasonably good revision control hygiene, you can revert your configurations to a known working state. So anytime you change something in your network, the revision control system will remember what you've done. You change your configuration, you tell the revision control system, hey, I have made this change, and the system will remember this for you. If at some point down the line, 5 minutes later or 6 months later, you realize, oh no, that change broke everything. Maybe moving from ISIS to OSPF or to static routes of the IGP was not a great idea. We should revert that and go back to the known working state. Revision control systems can do that for you. Just roll back to the previous state, pretend nothing happened. That's the first pass at things. So that's step one of your revision control adventure, is you can go back in time to something that worked. Step two of your revision control adventure is you can review changes before you deploy them to production. So you make your change, and then instead of making your change on a live network and typing commit at whatever piece of equipment you have, you type commit at Git, and Git makes it really easy to see the changes you're going to make. It's like show pipe compare on speeds. It shows you what you're going to do, and that little step of forcing you to look at the change you're making can help you realize what you've done wrong. And so you've made your change, you've changed your configuration. Now, let's read what have I actually done. So you type, configure, and then Git shows you, these are the changes you're about to make to your network. Turn off all BGP sessions. Maybe that's not a good idea. Git forces you to think, and before you deploy something potentially harmful to your network, Git will stop you. Well, Git is not going to stop you. You stop yourself, because Git shows you, hey, this is going to break. The third step of the adventure is Git will allow you, or revision control, any kind of revision control, I'm not married to Git, will let you recover configuration when your equipment breaks. If your configuration only lives on your equipment, if that piece of equipment breaks, your configuration breaks with it. If you then go and install a replacement machine, you need to rebuild your configuration from scratch and hope you can remember what it was. Whereas if your configuration lives in a configuration management tool, you just push it to the new device, and everything works. Finally, you can collaborate on projects without conflicts. So 2 of you or 3 of you or your entire team can look at the configuration you've got, and you can work together on a configuration before you push it into production. So if you're making sweeping changes, whoever's familiar with layer 2 can make the layer 2 changes, whoever is layer 3 makes the layer 3 changes, and then you go and review all the changes together, and then you push them in production and you go on holiday together while your network goes up in flames. Right, that's not what happens. One interesting point I want to make is that revision control or Git or any of these systems, they're not only for source code and for configuration. You can put anything in a revision control system. The system does not care. And that's where this presentation originally came up. The manners people were collaborating on a document. They were not collaborating on configurations. They weren't collaborating on code. They were writing a document together. So you can put anything into Git. It's really good at plain text things, but it can handle binaries as well. So potential things you can do with Git are internet drafts or network policy documents, training materials, or presentations such as this one. This particular one doesn't live in Git because I like pain and I'm using PowerPoint. But if you like even more pain, you can write your presentations in LaTeX or in Markdown or in whatever the flavor of the week is, put them in a revision control system together with some formatting goop. And that's what I do for workshops and other things that are not just ad hoc presentations that go off to lead a life of their So you can put anything you like in a revision control system. And once you develop this habit of putting everything you do in the revision control system, it becomes a lot easier over time. So, maybe if starting out with your network configuration feels like a bridge too far, start with the notes to yourself or your internal documentation and just move from there. So, several options for revision control, and the options are listed in increasing order of control, but also in increasing learning curve. So the first iteration of revision control is the total absence of revision control. You just have loose files all over the place, and your network more or less works. This is fine. I think this is where most people start. It's easy to learn because you're only learning about the equipment you're configuring. You're not you don't have to also go and learn a revision control system. Unfortunately, it's impossible to undo any changes. So your network, if any change you make, you need to remember what change you made if you want to undo it. The second pass at revision control is you start archiving your configurations for posterity. You just, you've got a known working version of the thing, you download it from all your equipment and you stick it on a share or in a Google Drive or in some other crime against humanity for reference later on. This allows you to at least audit your changes and roll back to previous revisions if you have to. But concurrent access becomes a nightmare, right? What do you do if two of you are writing to the same file? You end up with, configuration 1st of March 2024, known working. Configuration 1st of March 2024, testing the thing. And you end up with 4, 5, 6 dozen sets of files, and you don't actually know which one is in production. So it just becomes a nightmare. Finally, the last, the realization dawns, and you find real revision control, either CVS or Subversion or Git or anything, and you end up with low friction and full control, and everything is great. The problem is you have to actually learn how to use these systems, and that's what this talk is about. I'm not going to talk about chaos or archiving anymore. Let's talk about revision control. So basically, revision control looks a little bit like this. You've got your, if I walk around, the microphone is going to lose me. So I'm going to just wave at my screen and you just have to hope. So on the left side of this slide, you have your local computer where you have a checkout of your configuration. Those are the files in the green box. And you also have your version database. So version 1 of the file, 2 of the file, 3 of the file. So each version of the file you have locally on your computer. This is normal state of affairs. Even without version control, it all lives on your computer. With a centralized revision control system, your central system has your version database. So all of your files live in the version database on a central server, and the central server only has the version database. And you interact with the VCS system, with the version control system, by downloading the database on each computer. Computer A has this file, computer B has this file. You make your changes on each computer and you push them into the database. That's a centralized revision control system. That's how CVS works. That's how Git, not how Git works. That's how Subversion works. That's how any number of proprietary systems which have gone out of fashion used to work. The right side of the slide is how Git works. Git is a decentralized system, so all systems have a complete copy of the version database on them. Right, so the server on the top has your revision database, and each computer that needs it goes and downloads a complete copy of the repository and checks out its files. So computer A checks out the repository and checks out a working copy of it. Computer B does the same thing. They can talk to the server and they can talk to each other as well because they all have the same states. And the revision control algorithm is essentially sharing this state between you. Instead of sharing just files or diffs to files, you share the complete state of the revision control database. Right, so survival system. What's Git? Is it a content addressable file system? Is it something computer people use? Just something for software people? And why should your network people care? So let's talk a little bit about Git. According to the book or their webpage, Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Right, that's a lot of words. Some people are confused about GitHub and Git. GitHub is a company providing a cloud service around Git. You don't need GitHub to use Git. You can, but you don't have to. And there are several other companies that provide the same service as GitHub, and you can also host your own. We'll talk a little bit more about that later. The obligatory XKCD comic, Git is, nobody really understands how Git works. It's historically it was a bunch of Perl scripts that talked to a content addressable file system, and people just dealt with it. And when it broke, you just put your files away, you download a new copy of the repository, and you try again. And that gave Git a bad reputation. It's gotten a little bit better over time, but that's still a distressingly common way of working with Git. It's oh god, it broke. I can't remember how to get out of this position. Git is not doing what it's meant to do. Just throw everything away, check out a new copy, and try getting my changes in there again. The rest of this talk will hopefully help you do this a little bit less often. So another thing I would like to point out is that you should be nice to your future self. The other obligatory Git comic is that the value of your commit message decreases over time unless you practice a little bit of self-discipline. So it might feel like a chore to be presented with this. Please write a commit message explaining your changes. Fix all the things. I broke the network, make it work again. Yes, that's a valid comment, but it's not useful to your future self. So even when everything is on fire and your configuration changes make the flames go away, it helps to write a little bit of an essay about it. Should tell you or your future self or your colleagues or both why you made that change. So there's the what and the why to every network engineering adventure. It's what you do is important, obviously, but why you are doing it is at least as important. When you go back in time and you wonder what you have done to your network to end up in the state you are in now, the commit messages will tell you why. You can follow the breadcrumbs and go, yes, I was thinking this at the time. Yes, I was thinking that at the time. And then I did that. And then you can reconstruct the train of thought that led you to the station you're at now. So write good messages. Right, so Git has dozens and dozens and dozens and dozens and dozens of commands. I think I counted the number of lines in the Git manual page once, and it was a very large number. The good news is you do not have to learn all of them. I think about a dozen of commands is all you need to learn. And most of the commands you need to learn are very straightforward, right? So can anyone guess what a command like git add is possibly going to do? It's going to introduce a change to the repository, right? It's fairly self-explanatory what it does. So you manipulate files with add and remove. You initialize a repository with init and clone. Those are fairly easy to understand commands. Reviewing logs, git log and git show. The difference between them becomes clear over time. And then what's happening with your repository? Status, diff, undoing changes, resets, and checkout. And then working with others, fetch and rebase. This is really the only commands you need day to day. There are many others, but in a network engineering context, they usually don't come up. I don't remember ever using git merge or git cherry pick or git rebase -i with several other flags. I don't remember ever using these in a network. I use these in software. I don't use these in a network. So any command you can't really fathom is probably irrelevant for a network engineer. the other Philip made me put this slide in. Git also has GUI tools that actually, that can help you. So I live in a command line. User interfaces happen to other people. They're overwhelming. They're full of buttons, and they just confuse me. Git has two GUI tools that come in with the Git distribution. Both of them are completely useless. I don't know why they distribute them. They are useless. I have never found a use for them. So Git K lets you browse branches, and then Git GUI lets you write commit messages, which you then need to go and commit anyway. They're completely and utterly useless. Don't bother with them. If you insist on having a graphical user interface, you can use something called SourceTree from Atlassian, the nice people who make Jira and other unspeakable horrors. Confluence is the other one. They also make SourceTree. It's a fairly pretty little user interface, and it works fairly well. I've got a screenshot there. It's also free to use, and I think it works on a couple of different platforms. If GUIs are your thing, that's a free one that works. Sublime Merge charges you a token amount of money, $100, well, more or less token, depending on which economy you live in. It's also a very pretty one, and it works really well. So I've used that one under duress, and it's nice. I've actually got it on this laptop. I can show it later on if I've got a little bit of time. That's a nice one. And GitHub actually also has desktop clients, which are also free. And after I did this presentation, I realized that GitHub also has a web page. They are a web company. They're a complete website, and they have a web editor for Git. So if your revision or your stuff lives on GitHub, you can click the edit button on their web page, make your changes in a web browser window, click the commit button, and it'll go to the repository. All of that without leaving your web browser. If your life is in a web browser, which I understand is distressingly common for many people of this generation, then that might be the way to go. I don't think I could live that way, but I'm not here to tell you how to live your life. So if you like web browsers, that's great. I will see if I can do a 5-minute demo. Let's have a look. Last time I did this, Zoom crashed. So here we are in a fresh new project. Is it large enough? I think so. So I would like to start a new project. So let's start a new project. All right. I want to get this gone. There we go. So I have a new network. I have inheritance, or I'm building a new network. I found myself with a lot of money, a lot of new equipment. I'm starting a new network from scratch. It's great. I'm putting my configuration in a directory called my new network. Fantastic. Let's go and write a configuration file. Right. So I'm talking to a Juniper switch, and I'm telling it, do all the things and commit. All right, there we go. That's nice. That's my first configuration. My network works. So now I would like to store this in a Git repository, because I was listening to Philip's talk at some conference in Bangkok, and he told me, well, all configuration needs to live in a Git repository. How do you get your hands on a Git repository? Well, you create one. How do you create one? You create one with Git init. What repository do you want to create? Well, this one. Right, the current directory is dot. I would like to create a Git repository in the current directory. Done. You are now the proud owner of your very first Git repository. That was lots of fun. What do you think is in this Git repository now? Think there's anything in it? No, there's nothing in it. It's an empty Git repository. How do I find out? If I type git status, Git will tell me, well, there's no commits yet. Why are there no commits yet? Because we haven't made any commits. We've just initialized the repository. Git has gone and created a branch for us. Don't worry about what a branch is. I'll tell you later. It tells you you haven't made any commits yet. And it tells you, there's untracked files in this directory. I'm a Git repository responsible for the directory you are in. And I have found a file called config.txt, which I know nothing about. Until you tell Git about this directory, or about this file rather, it is not going to do anything useful for you. So it also gives you a little bit of helpful information for you, saying that if you want to put this file in the repository, maybe you should type git add. That would be a good start to do. And then, at the end, it reinforces this message, because anything you say to a network engineer once is forgotten. If you say it to them twice, they might remember it. So we do git add config.txt. Okay. What is this repository tracking now? How many commits are there in this repository? Still 0, right? So we do git status again, and Git tells us, well, we're still on the main branch because we've not touched the branch. You still haven't made any commits, but Philip, I typed git add. Yes, but you have not typed git commits. It's the same thing as a piece of network equipment. You can type any number of commands, but until you type commits, nothing is going to happen. But Git says, I have found a couple of changes which you still need to commit. You have told me about this file called config.txt. If you, go and type git commit, it'll commit it. But let's make things more interesting, and let's put things into a perspective which network engineers understand. What if we go and change our configuration now? We've not told the configuration management system, we've just realized that, I forgot something. We go and change our configuration file again, and we say, instead of doing all the things, let's do all the things correctly. So we save our configuration again, and we ask Git, hey, Git, what's happening now? Git says, hey, you're still on the main branch. You still haven't got any commits. I still can't travel backwards in time to what you have done before. You've told me about a couple of changes before, this config.txt file you have added, but you've made changes to this file since you introduced it to me. So now one thing you can do is you can already, so without having made a single commit, you can already do, git diff. And you can see, Git knows about doing all the things. My local copy knows about doing all the things correctly. I haven't told Git about that yet. So now I'm at a fork in the road. There are two things I can do. I can type git commits, and Git will commit do all the things. Or I can update Git's understanding of the current reality and just do git add again of this file. And now Git sees that, okay, the configuration you've told me about, I know about. You still haven't committed it, but there's no changes between what I know and what is in your current directory. Software engineers call this thing the index. You can call this the working copy. You can call this the configuration mode of your switch. It's morally equivalent. You can keep making changes and typing git add and git remove and anything else with Git until you type git commits. It's not in the revision control system. And this is a really powerful tool. You can keep doing diffs between your working copy and what goes into the repository until you are happy with them. You don't have to type git commits after every one-line change you make, because then you end up with pages and pages of do all the things. My hands are typing, but I don't know where to go. You end up with all of this useless revision control information. Instead, you can iterate in your index, in your local working state for a while until you are happy with this change, right? So once you are happy with the change you've made, you can go and do a git diff minus cached, which shows you what Git knows about your current state of affairs. Dear Git, please tell me what change I'm about to commit. You can make an alias for this if you like. I just type whatever the command is. We'll talk about aliases a little later. And Git will tell you, well, if you type commit now, this is what's going into the repository. So let's type git commit, and Git throws up a little editor window and asks you, well, describe what you have done. Do stuff and things. That would be a terrible, terrible commit message to write, because your future self would look at this and go, now I have to go and read what the actual change was. And do that often enough, and your revision control history is worthless to you. Instead, you can write something like, I'm not too sure about, I don't know, something like that. You write a little, write a little essay to yourself, what exactly have I done? And then at a future date, so let's commit this, we save this file, and now we do git status. Git tells us, you're on the main branch, you have nothing to commit, your working tree is clean, so there are commits, you have no new ones, and your current working directory is in sync with what's in the repository, right? So you've now made this commit, and you can type git log to show you what's been done, and you see a useful essay to yourself. Hey, I have made an initial revision, my layer 2 works, layer 3, nothing done, and I'm not sure about the authentication, right? You can go and look at this message at some point in the future, and it tells you something meaningful about your state of mind at the time you made this. So get in the habit of writing these good messages, and you'll go far. And also get in the habit of not committing things that are incomplete. You can keep iterating over Git for as long as you like until you are happy with the state of your working directory. If you do that, you will find it a lot easier to live with Git. It's really easy to commit things to Git, and Git will make it really, really difficult for you to lose data. But you don't have to commit to have a good time with Git. You don't actually have to commit things to see changes. You can keep working with the index or with your staging area to get your local copy in a state you like before you commit it to the repository, right? This is a very powerful little tool. The other two commands I was going to show, git log shows you what changes have been made to the repository, and it only shows you the message. And git show shows you the message and the actual change that was made. So how many commands have we learned so far? Git add, well, git init, git add, git diff, git commit, git log, git show. That's 6 commands in 10 minutes, right? And they're fairly straightforward, right? They're not long incantations in foreign languages. It's short words, easy to grasp. So let's go back to the slides for a bit. So creating a new repository, git init. Adding a file to the staging area, so to Git's understanding of the current working directory, git add. Committing a change, git commit, and showing the history of your project, git log. Very simple. So let's do a little bit more background. What does Git actually store in the repository? Git stores a series of snapshots. So every time you type git commit, it takes a snapshot of the staging area and your current repository, and it puts them together. So it takes it takes what you have done with git add, it makes a little log of this, and it stores that. So it stores snapshots, and it refers to these snapshots by the hash over the contents. So Git stores, Git remembers the things that are in the repository by the checksum of the things that are in the repository. Software people would call this a content addressable file system. It's just, it's just a very convenient way of storing things. And it also helps with internal referential integrity in the system. It makes it really difficult for Git repositories to become corrupted because of the way Git stores its data. Also, the keen eye will have spotted that I have not talked to a single server here. I have done this all local. Most Git operations are completely local. They're only on your computer. They don't interact with any network. You can push your repository to another system and you can pull repositories down from other systems, those are network interactions. But all of the interactions you do with Git by itself are completely local to your machine. So you can go off and sit on an airplane for a couple of hours and get real work done. You can end up with, dozens of commits, and then you get to your destination and you type git push and you break the network for everyone with a storm of commits going in. That's, I wouldn't recommend this approach, but this is something you can do. More usefully, you can go and sit on an airplane for a few hours. You can make all these changes, and you can, manipulate and meddle with your history. You can rewrite history as much as you like while you're on this flight. Then you arrive at your destination. You test all these changes in your digital twin of your lab, and then you push them into production. Right. Git also generally only adds data. It is incredibly difficult to lose data once it's been committed. Until you've committed it, Git can forget, and you can make Git forget just about anything. But once it's committed, it's really difficult to lose data. I won't say it's impossible, but it's really difficult to lose data once it's been committed. A little bit about terminology. States and the index. I keep calling it the index. I think modern Git's terminology is the staging area. That's two words for one thing. But Git has three main states. You have modified files. So if Git tells you I'm in the modified state, it means that you have files which Git knows about that have uncommitted changes. So there's a file in the repository. You've made a change to it. Git calls that a modified repository. If you have staged files that will be written to the repository on the next commits, Git calls that, things in the staged change. Your repository is now staged. You've added things. You've done git adds, or you've done git rm. You've done something to your working directory to tell Git some things. You are now in the staged state. Finally, committed changes are the ones that are safely stored. So they come with both the change you've made and the little essay you wrote to tell Git about the changes. Finally, not really a state, but untracked files. Git will tell you if you've got things in your working directory that it doesn't know about. I showed you that earlier. There are untracked files in this repository. Git knows that these files are there, but it doesn't really know about these files. So they're untracked, they're not safe, right? Does that make sense? So there's a little diagram here for people who like looking at arrows. So the staging area is your current working directory. You stage files by typing git add. So from your working directory, follow the little arrow to the right, files go into the staging area. And once you type git commits, they go from the staging area into the repository. And the repository lives in a .git directory. And you check out your project by taking what's in the Git directory into your working directory. So that's what git clone does. That's what git checkout does. Does that make sense? You can ask questions. I don't bite. So another little state machine. This is what happens in diagram fashion when you make changes. So you have an untracked file, a brand new configuration file. It's untracked. You add the file to the repository, it becomes staged. Git adds, it's now gone from untracked to being staged. Git knows about this file, but you've not committed it yet. If you then go and, or if you take an unmodified file and you go and edit it, Git goes into the modified state. If you then go and Git adds the modified file, you're back in the staged state. Right? From the staged states, you can go to unmodified by making a commit. And if you have a file that has never been added and you remove it, it becomes untracked. If you remove a file that Git does know about, you're modified, because removing a file modifies the known states of the repository. So all of the changes you make in your current directory operate on this index. So if you remember these 4 states in your head, it becomes a little bit easier to understand what Git is doing. So if you edit a file, you go to modified. If you remove a file that exists, you also go into modified, right? So let's show that again. Go back to my little directory here. So we're staying in the same directory. We're not doing the thing the comic said about throwing everything away. We are still in our directory. We have one log message. We have one commit in the repository, affectionately known as 02F0, blah, 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 blah. And it's got our initial revision. If we now go and, well, let's just remove this configuration. We are not happy with it, right? We're just throwing it away. Just remove this file. Oop, type it right. Git is very helpful. It also tells you, if you make a typo, Git will helpfully tell you you've probably made a typo. So we had a file called config.txt in our repository. It was known to Git. There was a little log essay about its addition. We went and removed this file, remove my configuration. Git tells us, well, you're still on the main branch because you've not changed to another branch. You have changes that are not staged for a commit. You have deleted this file. Git still knows about the file, but it's not here, right? So if you wanted to get this file back, oh no, I've removed the file, I want it back. How would you get it back? You can do git restore, restore config text. And there's my file back, right? So you've thrown the file away, Git remembers that the file is there, you can do git restore to get your file back, right? You can make a change to this file. Let's make a change to this file. Let's do things more correctly. We change this file. So we ask Git, hey, what's the difference between my working copy and what you know about? Well, you were doing things correctly. Now you're going to do things more correctly, right? So Git knows about this. If we do git status, Git says, well, you're on the main branch. You have made a change to this file. You have modified this file. And if you want, if you are happy with these modifications, you can do git add. If you are not happy with these modifications, well, you can do git restore. So git restore will get our file back in the state it was in before. If we do git add, we go git add, we ask Git what's the status of our repository now. Well, you're still, you have not made a commit yet, but you've made these changes that are about to be committed. You can still change your mind on them because you've not committed them yet, but I know about them now, right? So now we can do a commit. Git asks us for a little essay, and we can type, that, and that would be a really terrible idea. So instead, we type a nice little essay to ourselves, or something like that. You write a nice little essay to yourself, which, if a few months down the line you come and read it, you can use to fish up your mental state. So we go and commit this. Now we go and look at the log, and Git goes, well, a while ago at 10 o'clock, you told me about your initial revision. 15 minutes later, you made a second revision. You could now, if your second revision turns out to be a terrible idea, you can travel backwards in time and fish this one up again. You can check out the state of the repository at that time, and you can make that change go away, right? If you wanted to see what was done in this commit, you can do git show, and Git will tell you, hey, the previous state of affairs was do things correctly. The new state of affairs is do things more correctly. And here's a little essay that tells you what was done, right? So this is very powerful sort of thing. So every time you're in your working directory, you can do things like git add, and you can do things like git add minus patch, which I've not shown yet, but I'll do shortly, to manipulate your index, so your staging area for Git, until you're ready to commit things. And you can do git restore to undo your local changes until you're happy with what's in the index. And you can keep typing git status and git diff to show you the differences between what's in your actual repository and what's in your staging area. And you keep doing these things, and it becomes the first command you type after every other command. They're just there. And it's muscle memory. I forgot about git add minus patch. I can do that now. I've made a bunch of changes to my file. I do git status. Git tells me, yes, you have changes to this file. You do git diff. Git shows you what the changes are to this file. If you're happy with some of these changes, but not all of these changes, so if you do git add, it will add all of the changes. If you do git add minus patch, Git will say, well, do you want to stage all of these changes? And you can say, well, no, not really. I would like to edit them. E for edit. I'd like to edit some of these changes before I stage them. So I was happy with this change, do things more or less correctly. I was happy with that, but I don't like stuff and things. So Git says, to remove plus lines, just delete them. So let's do exactly that. I'm not happy with this line. So I go and delete this line. And I save my file again. And then I do git status. And Git says, well, things have changed. You have made changes to your files. These changes are going to be committed. If you don't want them to be committed, you can do git restore. And I will forget all about them. You've also made changes that you have not added to the repository. So if I do git diff now, I will see I have one local change. So the change is still in my local directory, but it's not ready to be added to the Git repository. So I've not lost anything. I've just said I'm not quite ready to commit this to the repository. Keep it local, but don't add it to the commit message. So if I type git commit now, it will commit everything except for that last line. That makes sense? I'm not going to commit this one because there's no point. But you can keep doing this. You don't have to work like this. You can do your changes piecemeal, but Git makes it easy for you to rewrite your states into useful chunks. And this is particularly useful when you're collaborating with other people. Try to make your changes in a way that they can fit together nicely. You don't have to put all the things into one commit. Disk space is cheap. You can have hundreds of commits. So break your changes down into things that can be described in a nice little commit message and commit them separately. So I can go and commit this one and break all my rules, do most of the things. Don't write commit messages like this, write nice little essays. So I'll commit this one. Git says, well, we're back in the modified state because you still have changes that you have not committed. We do git diff. Git says, well, stuff and things is still local, but it's not in your repository. We can do git show. Says, well, do most of the things. These are most of our changes. This is what I've committed to the repository. I can now make a second commit. I can do git add config. And I can commit this change and say, do that. And I go and look at my logs and this message, so this commit is only stuff and things. And the one before that, I'm teaching you a nice little shortcut. Show the previous one. The previous one has a little hat. Do most of the things, right? How do you think you travel farther back in time? Any guesses? How would I see the commit before that one? I type another hat. The one before that, another hat. Keep adding hats, right? So I'll tell you about head later. So keep typing this, and Git shows you all of these things. You can also, you can look at your log. You get log. Git tells you these are all your commits. This one, this one, this one, this one. These are all your commits. If you want to see one of them, you can just do, the long hash, and Git tells you that commits. So you can show your commits relative to the current one with heads and hats on your head, or you can show the one by hash. All right, so Git log shows you your logs. Git show shows you the top one. The top one is also the heads, because the head is on top. So Git show heads. This is the top one. Put a hat on your heads. It's the one before that. 2 hats, 3 hats, 4 hats, 5 hats, all the hats. If you type too many hats, Git will say, there's no such revision. You do not have enough hats. Right. How much time have I got? How am I doing? Oh, I'm doing well. So let's talk a little bit about branches. This is where people usually get lost in the wonderful world of Git. Is what on earth is a branch? A branch is nothing more than a named pointer known to Git. And I've lost everyone. Great. So these things are hideous, right? They're disgusting. They're horrible. You can't pronounce them. You certainly can't remember them. A branch is a named pointer, is a nicer name for that long string of letters and numbers that Git knows about. In a normal, standard, happy, friendly new repository, you'll have 2 pointers. You'll have the master pointer and the heads pointing at master. In newer versions of Git, master is called main, but let's not drift into that philosophical discussion. It has a name. It could be called Alfred. It could be called Jane. It could be called anything. It's just a label. It's just a pointer. Internal to Git is the long SHA-1 hash of things. So in this diagram, I have a commit message, or a commit known as F30AB. That's hideous. You can't remember it. Git also has a label on it called master, and it has an extra little label on it called head. Every time you do Git branch, Git will change to another little label. So Git makes it really, really easy to switch your working states between all of these little labels. And it does this, so you can easily keep track of where you are by looking at head. Right, so the heads also always points at the current commits. Wherever you go in Git, the head points at where you are. So everything you do in Git is relative to the head. So let's do a little demo of this. Try to remind myself what I did in this demo. Okay. So we are currently, Git status, we are currently on the main branch. The key and I will have observed that I put these things in my prompt. You can do that. You can go wild with this. There's people who put all sorts of information in their shell prompts. I just put the current branch there because that's the only thing I really care about. If I wanted another branch, let's say I want to test some things, I do git branch tests. What happens? Seemingly nothing happens. Right? I am still on the main branch. But I just did git branch tests. Why did nothing change? Well, you told Git to create a label called tests. You didn't tell Git to change to this label. Also, git log also, they're the same. This commits, the head is pointing here, the label main is pointing here, and the label test is also pointing here. You've not actually changed anything. You're still on the same place. You've just added a little label to it. If you want to change Git's branch, the branch you are on, you need to check that branch out. So if we do git checkout tests, we have now switched to the branch tests. Git log. We've switched to the branch tests. Our head is pointing to tests. Main is also here, but our head is pointing at the test label, not at the main label. Currently, it doesn't matter because tests and main and head are all pointing at the same commit object underneath, but you've got this extra label. If you make new commits now, they'll go on the test branch, not on the main branch. So we can change things. Yep. I've lost my command line. Oh. Okay, I've made a mess of things, but that's okay. I have an untracked file called stuff text. So let's just add that file to the repository. Git add stuff text, git commits, add the stuff text file. There we go. If I do git log again, I see all of the things, but I see that the head points at test, and the main branch lives on this little label. So if I now go back to my main branch and I do git log, there is no message, no mention of the stuff text file. Stuff text only lives on the test branch. It does not live on the main branch. How do I go back to the test branch? Check out tests. And I do git log, and the stuff text file is there, right? So the branches in Git are just labels on snapshots, and you could move freely between all the snapshots. And your working directory to Git is just, it's just there. And as long as your working directory doesn't change, Git will let you move freely between your states. If you make changes, moving between branches, Git will tell you, hey, you should commit changes, or you should forget changes. But you can move freely between branches by simply moving the head pointer around. So you can do, and you can make diffs and statuses between branches if you like. So you can do git log of a branch. It'll show you what's happened on that branch. You can do git diff between branches to see what's the difference between my main branch and my test branch. So you can, for a network engineer, this is you sitting on an airplane making a bunch of changes. You'll then push this test branch into your staging environment, your lab, before you merge it into your main branch and push it into production. Right. So a graphical representation of the things I did earlier. We were in a state where we had our little commit here. Master was pointing there and the head was pointing there. We added a little label called testing. So git branch test or testing in the diagram just adds an extra little label to this commit. The commit hasn't changed. Nothing has changed except I've now got 3 labels pointing instead of 2. If I switch the branch, all I am doing is I'm moving head from pointing at master to head pointing at testing. Underneath, they're all pointing to the same thing, but my head is screwed on differently. It's still the same head, but it's screwed on the other way around. If I commit a change to a branch, what happens is a new commit is manufactured. Git learns about a new state, a new snapshot is created. The label testing and the label head are on that new change, but the master label is still attached to the previous change. And the previous change is still there, and so are all the other changes. So Git will only ever add things. Every time you do a commit, Git will make a new little gray box like this. And it'll keep adding little gray boxes, and your life with Git is keeping track of the little labels on the boxes. If you switch to another branch, you do git checkout, you move your head to another label. So git checkout master or checkout main in my terminal example, this commit is still there. It hasn't moved, it hasn't gone away. It still has the testing label on it as well, but we have moved our head to master. So the state of the repository we see is whatever was on the master branch. And that's really the fundamental concept of Git, is you move your head around. The commits are just there, and they will be there forever. It's really, really difficult to get rid of any of these commits. It involves rewriting history and doing all sorts of other things. It's really, really difficult to do things as long as you remember to move your heads to the correct one. You can always go back to any state in the repository. And git checkout is the way to do this. So you can do git checkout with a label, but you can also do git checkout with the name of any, or the number, the hash of any of these commits. If you completely lost your way in the forest of git commits and all you have is git log, you can still do git checkout of any of those hashes, and Git will go there and your current directory will reflect the state of the repository at that time. So I can go here, I can do git log, and I've, head is pointing at tests, main is pointing here, but both of these are wrong. And what I want is this. This state was the one where everything was correct. I can do git checkout that. Git says you are in a detached head state, which sounds a lot worse than it really is. It sounds pretty gruesome. Git says, you're in an attached head state. You can look around, you can do whatever you like. But, if you want to create branches or if you want to create changes, you should put a little label on them so that you can remember them later. You don't have to. So Git gives you just enough rope to hang yourself with. What you do with Git is up to you. If you want to create commits in detached heads, that's fine, but then it's up to you to remember what they are. So stay on a branch and then, manipulate the branch labels, and it's going to be much better. But if you find yourself with this on your screen, don't panic. Just remember what Philip says. Oh, I'm on one of these commits, which does not have a little label on it. How do I get out of this state? Well, I do git checkout to whatever branch was there, or I create a new branch off here. Right? I can do git branch here, and then and it'll create a branch label at this place, and I can move on from there. Do I want to do that right now? No, because it'll drift us off further into the forest. And to network engineers, this is not the state you want to be in. If you find yourself with this message on the screen, you have done something wrong. You just go back, git checkout main or git checkout master. Just go back to the last stage with a label. How do you know the last stage with a label? Well, git log will tell you. Look at the right side of your git log. It'll tell you all the little labels that are there. Pick the label you want and step backwards from there. But when you see the message about attached heads, don't panic and throw everything away. Just think back and go, oh, right, now I know what this means. It means I have a head label that's pointing at something without another label. Nice little survival trick. All right, let's talk about divergent histories. If you make a change on one branch and not on another branch, you can use git checkout to change between them. You can see different tracks of history by using git checkout because everything here is just a branch. Right? So graphically, this is what that looks like. And you are allowed to draw things on pieces of paper while you're working. If it helps to draw little diagrams like this to see the state of the repository more clearly, go do that, right? But in a normal network engineering environment, you'll never really find yourself with diverging histories. Try to just step back in time to where it looked the way you thought it did, and you'll have a much better time of it. So, don't think I have quite enough time to do this, but sure, I can do this. So, a nice little trick, and one of the commands which was not on my survival list is git reflog, which tells you where you've been most recently. So Git remembers not only your changes and the messages you associate with them, but Git also remembers what you've done in any given repository, and it keeps it in a reflog. So every time you move from one branch to another, Git will remember. So if you're in an attached head state or you've been typing things at Git for the last half hour and you're lost, try typing git reflog and it will tell you in it'll tell you where you are, what you've done. So this is a very testy repository. I've not done much here, but if I go to a real repository where I've been working for a long time, the reflog will be several screenfuls of things, and it's actually quite helpful to see where I've been and what I've done. So if I, what was I going to demo in this slide? I was going to do a reset and do a branch. Oh yeah, okay. So I'll go to my test branch and I have one commit here, I'll make another one. Right, so you type a nice, good commit message, which will remind you of all the things. So we do a git log here, and we have our head pointing at tests. We have a couple of commits that are only on tests but not on main. If I wanted to go to main, I do git checkout main. If I look at the log of main, I have no mention of those two other commits I had earlier. I can do git reset tests. And what that is going to do is that's going to pull in all the changes that exist on tests into here. So I can do a git diff, and it has pulled in all the changes that exist on the test branch, which apparently is the addition of stuff text and things. It's pulled those changes in. That's not a very useful thing to do. You've just taken the changes and you've pulled them here. So we don't really want this, right? How do we get back to our known good state here? We do a git restore. Oh. Got it right. And things. So I've just restored my known state. So git reset does exactly what it says on the tins. It resets your working directory to whatever was on the branch. You usually don't want to type git reset. Git checkout is the command you want. Git checkout puts you on that branch and gives you the logs as well. So git checkout tests. This is where your changes are. So reset is not what you want. Reset just changes your current state to what's on another branch. But git reflog now, so git reflog will tell us the things that have happened here. So I've made a commit to the main branch, or to the test branch rather. I've made a commit here. I've said I've done a checkout. I've moved my head from test to main. And then it says a reset. I moved to tests. I took the changes that were in test and I moved the changes here. That's, the reflog tells you what you have done to end up in this state. And then I've done a checkout. I've moved back from main to tests. Right, so the reflog can help you with the little breadcrumbs of where have I been? How did I get here? So far, that was all local repositories. I said earlier at the very beginning that Git is a distributed revision control system. So you can add remote repositories to share your stuff with other people. So on your local computer, you have all of the versions and your files. Someone else on their computer has all of the versions and all of the files. And you can have a central server which has all of the versions. It can also have all of the files, but usually on a central server, you don't check out anything. You just have a bare clone of the things in there. And the way Git works with multiple repositories or with multiple clones of the repository like this is it manipulates the state changes between these repositories. So a local clone or a remote in Git terms is just a complete clone of the complete repository with all of its history. So this is different to CVS, where every checkout is just the files. In Git, a clone represents the entire state of the repository. And this makes collaborating on changes really easy because everyone has all the changes. right? So there's several workflows that you can use with different levels of complexity, but for network engineers, none of that's really relevant, because usually what happens in a network context is everyone just works with a central server and you pull changes from it and you push changes to it. And on a network, history is also mostly linear, because your network represents a real world state of affairs. You're not going to have two real world states of affairs. There is one network, right? So in a networking world, you're usually, all your colleagues are pushing to the same repository, and then often there's some automation on that repository that goes and manipulates state on the network, and you're just pushing and pulling everyone from that same repository. Software people might push changes between them until they're happy with them. You can do that as network engineers as well. If you're, working closely with a colleague, you can send your patches to the colleague before you push them to the repository, or before they push them to the repository. You can do that. That's a workflow that works, but it's usually not something you'll encounter in a network. In a network, you usually push to a central repository. Give a quick demo of that. And I can also do this locally. So what I can do, how was I going to do this? I was going to go back, and I was going to I have just done a sneaky thing, which you do not need to worry about. So I'm going to I'm in here, and I'm going to collaborate with someone else on this repository. I'm going to git remote add trouble, and trouble's repository is in there, right? So go back and look at the slides if you want to understand this better. Morally, this is the same as doing git clone from GitHub and then git remote adds to GitHub. I've just told Git there's a remote repository which I am collaborating with. I can now go and git checkout main. I'll go back to the main branch, and I'll put some things here. So I've just made another commit here, git log, this commit is there. If I go to here, and I'm now, I'm a new colleague, and I'm collaborating on the same network with me. My schizophrenia is really giving me a hard time today. I'm going to clone this repository from my colleague. So I do a git clone, my other network. So I'm cloning where you see my other network here. Think GitHub, think your centralized server at work, think anything you like. I'm going to clone this repository into a remote clone. So I'll just do that. I go into here. This repository does not have the change I just made, right? Because that change was never pushed. I've made that change locally. If I go back to my original one, if I go back to here, this one has the things commits, but it's also got changes to share, right? If I want to share these changes with other people, I will push those changes. Oh, but Git says there's no upstream branch. I have told Git about a remote repository, but I have not told Git about the branch on the remote repository. Git will helpfully tell you, I found one remote clone you probably want to push there, and that's exactly what you want to do. So git push set upstream trouble, and it's main I wanted to push. So what I'm pushing to this other repository is I'm pushing my main branch to the upstream repository called trouble, right? Oh, and Git has gone and done that. So that's only the first time. Once you've told Git about your upstream, it'll remember it. So if I make another commit now, if I make another commit now, I can just do git push, because Git has remembered that my upstream repository is trouble. So I've pushed these two changes. So we were originally at things, I've made two changes and I've gone and pushed them. If I go back to my remote clone, this one doesn't know about it because this repository was cloned when my remote was at the state things. How do you think I get my changes in here? Well, I did push to get them into the shared repository. The opposite of push is pull. If I pull git log, I have, trick question. I have done git log. Git pull showed me that things happened, right? Somewhere. I did git pull, but I'm not seeing my changes. What happens? Anyone? Can anyone see what's wrong? Do you see what I've done? Tuxo knows. Remember that Git remembers branches as well. So I have pulled changes, and my repository, my clone, is the entire repository. It's not just the main branch. It's not just the working directory. It's everything. The commits I have made were on the main branch. This repository is on the test branch. If I go to the main branch in this directory, I will see my two commits. So Git manipulates state change, complete changes to the repository. If you push commits to a certain branch, someone who pulls the whole repository is going to see those changes in their Git repository. But if they're on another branch, they won't show up in the directory. So Git pull does exactly what it says on the tin. It pulls changes to the repository. It doesn't make any change to your working directory necessarily. It doesn't change your where your head points. It only pulls those changes. If you want to see those changes, you might need to move to whatever branch it was. So remember that when you're manipulating Git is, you remember the changes are there, but you also need to move your little label around, right? More troublemakers walk into the room. So we've done a couple of things. We've done a git remote add. We've added a remote repository. We've pushed some changes into the remote repository, and then we've pulled them back. When we pulled them back, we noticed, hey, we've pulled changes, but we can't see them because we were on a different branch. So, this is combining the knowledge of branches and the knowledge of things. You can fetch changes without merging them in. You can just do fetch, and it'll know about the changes, but it won't actually update any of your labels. That's more advanced use. You can keep looking at the slides if you like. We've only got a couple of minutes left, so I'll rush through the rest. Push and pull work with the entire repository states. You can it doesn't change your working directory, it just pushes your changes. All right, so a couple of minutes left to talk about GitHub and GitLab and all those things. GitHub essentially provides hosting for Git repositories. You push, I did a manipulation on my file system. I created my remote repository in another directory on my file system. You can create this repository on another remote file system in your network if you like as well, but you can also push it to GitHub. So GitHub is mostly targeted at software projects, but it's good for any Git repository. And you can, give them a token amount of money to keep private repositories, and they can serve as backups, right? So and you interact with GitHub by pushing and pulling changes from them. So you just do a git push to push things into GitHub and a git pull to pull things back out of GitHub. GitHub also gives you a bunch of other things like wikis and project management and issue trackers and bug systems and all of that stuff, which you may or may not need. But fundamentally, it's a place to store your Git repositories. So if you need another external backup of your network configuration, GitHub can do that for you. if you want to collaborate on network configuration or internet drafts or other things with other people, GitHub can do that too. It's got a nice little web interface to show you changes between repositories. The workflow of GitHub is more or less the same as what I've just shown in my Drive demo here. You fork a repository from a project, which basically means ask Git to make a copy for you under your namespace. You clone your fork, you do git clone of your fork, you make your changes on a branch, you then push that branch into your namespace on GitHub, and you tell your friends about it using GitHub pull requests, and they go pull them in. And so the workflow on GitHub is basically you push changes into GitHub, you talk about them on GitHub, and then someone, pulls them into their repository. Or you have your centralized repository on GitHub, you all push changes into it, you discuss them until you end up with a state there that you can all agree about. GitLab is another implementation of the same paradigm. It's an open source project, but they will also host repositories for you for a fee, but you can run this locally. So if you don't want to share your network configuration with GitHub because they're competitors, or because you don't want, because you have policies of not sharing your network configuration with other people, you can self-host. So you can have GitLab, which gives you all of the collaboration tools of GitHub without having to be a customer or a user of GitHub, right? You don't have to use GitLab though, right? So GitLab only gives you all of the collaboration features of GitHub. It gives you issue tracking and bug reporting and wikis and project management and all that goop. If all you need is the repository, then all you do is you set up a centralized machine and you git push to that one. You don't need GitLab. You don't need the overhead of that. You can just push to a directory. And you can, the first pass of it can be NFS mounted directory somewhere in your network and everyone pushes to that. That's okay. Or you can, Git can push over SSH. You can just SSH to your colleague's laptop and push there. That's also fine, right? The fundamentally all you're doing is sharing the differences between your repository and theirs. Bitbucket, same theme, same thing. It's if you're an Atlassian shop and you use Jira, Confluence, and all the other stuff, they'll sell you Bitbucket as well. And it does the same thing as GitHub and GitLab, and it's just a centralized repository. So the original time I did this, I had time for a GitHub demo, but we only got 5 minutes, and I'd be laboring the points. So I'll break for questions, and I'll say some credits here. So most of the images in this presentation I took from the Pro Git book, which is free. You can go to their webpage and you can find it, and you too can use their diagrams as long as you credit them. They're very. I like the little diagrams. They make it a lot easier to understand what Git is doing than just looking at the logs. I'm more of a software engineering person originally, so I think of it as a content addressable file system, and the little diagrams really help. Knowing that what I'm doing is I'm just creating little gray boxes and putting colorful labels on them really helps with my understanding of Git. It might help with yours. So the Git book is very handy to read. There's a GitHub cheat sheet on training.github.com, which shows you all of these commands and more. And then there's a little chart here, which this link didn't work this morning. I think he's taken it down. It's a little flow chart. I'll try to find a mirror. Is a flow chart of a Git mess and how to get out of it. So you've got a detached head. What do I do to get out of it? I've got unmodified changes. What do I do to get out of it? Take a look at these slides. They're on the Apricot webpage. Download them and go through them at your leisure. And if you have any more questions, you can always just send me email, and I might even respond. And that puts me almost exactly on time.
Thanks, Philip. Have we got any questions in the room?
Anyone awake?
Actually, I do have a question. Just in terms of, say, you're working with a colleague and you each make a branch working on the same file, and you go to merge it back into, say, the main, how would you sort of rectify that? Is that using Rebase?
Yes, I would do rebase. So, well, let's try that out in the 3 minutes we have left. So I will, in my remote clone, let's engineer a merge conflict. All right, let's push this change. There we go. And let's go back to my other network. Let's go to, well, let's go to main, because that's probably what, oops. Oh, this is the wrong one. It's here, right? Yes. If I do git pull now, it's going to shriek. It's not going to shriek because I haven't got a merge conflict. I didn't do it badly enough. I didn't break it badly enough. Rats. Well, it was worth a try. What Git would do is it would offer you to merge the changes, and then you could go off on a branch, merge the changes in that branch, and then rebase your main branch from that branch. We can have a quick session on that offline. When you try to engineer a merge conflict, you can't do it. Let's try that again. We've got 2 more minutes. And I didn't. Okay, so one change here. I have one change here. Let's push this one. Okay. So I've tried harder to engineer a merge conflict. So if I do git, well, if I do git push, you're going to shriek. Right. So I do git push and it shrieks, merge conflict, everything is terrible, you're not having a good time, throw everything away, start over, and pull your changes back in from your temporary directory. Or do a git pull. Aha. Hooray! I have engineered a merge conflict. Git says, I have lost my tiny little mind. You have tried to pull changes from a remote repository called my other network. I've pulled these bunch of changes into my branch. I have tried to merge them for you, but I am not smart enough. I am but a stupid little computer and I don't know what to do. So it gives us a hint: resolve all conflicts manually and mark them as resolved until done. So what we do is we go and do a git diff. We check what's happening here, right? So I've made a bunch of changes in my repository. My colleague has gone and made a bunch of changes in his repository. I'm trying to merge them in. So let's go and look at our config file and see, okay, which of this do I want to salvage? So the head, this is me. So I'm the head. These are changes I've made. Do I feel strongly about this change? Well, okay, I'll feel strongly about that change. So I remove the conflict markers and I'm now happy with this bit. And then this is what's my, right, this was my state and this was my colleague's state. I'm not unhappy with my change here, so I would like this. But I'd also like the fail and shriek. So let's remove the conflict marker and keep that line as well. And I'm happy with the repository like this. Let's take this line away as well. Right. So if I've made changes, I've put my working copy in a state I am happy with. So let's save this and let's look at a diff. So I look at a diff. This diff is against my staging area or my perception of reality. If I commit these changes, or if I git add and git commit these changes, this is what's going to end up in the repository. So let's do that. Git status. Let's do a git add of config.txt. Git says both of you have modified this file. We've gone and edited it, and I've merged the changes by hand. I've changed the file if I like, so I'm now adding it. And to add a commit to the repository, I do a git commit. And we'll resolve this conflict. Right, so I'll resolve my conflict. I create a new commit message, and tell Git to continue rebasing. Git will show I've now manufactured a new commit. I've manufactured a new commit that has the changes merged in with my colleagues' changes. And I can go push this one because that's fine. If I then go back to my other repository and my colleague, she goes and clones it, it doesn't conflict because I've merged her changes into mine. Right, does that make sense? There's other strategies for doing this. You can go and do these changes on a branch, and then you can argue about these changes on the branch. But if it's straightforward, just do it on the main line, manufacture a new commit, push it up, and you're back in sync. And doing it this way, that's an alias, git log graph. Doing it this way, your history stays linear. It stays a straight line. If you go and do it on a branch, you end up with stair-stepping history, which I think is unsightly, but some people seem to be very fond of. Right. So don't be afraid when Git shrieks. Just remember that, oh, my view of the world is out of sync with their view of the world, and what I want to do is reconcile. And Git makes it remember that Git makes it really hard for you to lose data. If you don't like what happens, you can also do git rebase minus abort. Your repository stays in the shape you had it, and their changes will end up on a branch. And you can always go and look at their branch and come back because you have them locally now.
Right.
Good question.
Thank you.
Any other questions? Closed today because of yesterday. Everyone was at the popcorn session. All right. Thank you, everyone. I think this is recorded, so you can go watch it if you have trouble sleeping. And I think there's previous iterations of this one as well. It's a different tutorial every time I teach it. So go off and watch the other versions if you didn't like this one. Thank you very much. I hope that was fun.